Good morning, everybody, or afternoon, wherever you are in the world. Today's exercise that we're going to be doing is georeferencing. We are downloading images off of the internet all the time, and we want to put those in real-world coordinates sometimes. If you look at a list of videos that I have on this channel, you'll notice that there is already a georeferencing video. But that one was a pretty simple video of if you have an image and you don't know coordinates and you just want to visually match known points to each other, that's what that video is about. This video, on the other hand, is if we know the coordinates of our ground control, we can assign those points to our image and then rectify that image to match our map data. So this one's a little bit more precise. It's another way of georeferencing a TIFF or a JPEG or a PNG file or whatever image that you download. If you know the control points, you can enter those in to have actual coordinates of those points. So in our example, I'm using the state of Utah, because I have 6 relatively easy points to put in. So I have 2 images. This first image is probably a Mercator projection because the lines of latitude and the lines of longitude meet at relatively 90 degrees. And they're pretty straight north and south, east and west. Okay. The other image that I have is the same state. Okay. But if you notice, lines of latitude seem to kind of curve, and the lines of longitude converge as we move north. So this is telling me that this is probably some kind of conic projection. Okay? It's important that when you georeference an image that you have some kind of an idea of what the source map projection was used. All right? It doesn't have to be exact. You don't have to have it perfect, but something that's really, really, really close, if you can. All right? You just have to do your best. All right, so what I'm going to do is I'm going to remove the conic projection. So we just have our first image that I think is probably a Mercator projection. And I'm going to, in ArcGIS, I'm going to set the layer property to the map projection that I think that image is in. All right, so I have some favorite map projections that I've used over a period of time, and I just so happen to have the NAD 1983 projection in my favorites list. So I'm going to go ahead and choose that one because I think that that's pretty close to what my image is. So I click OK, and that sets that layer property to that map projection. The next thing that we're going to do is we're going to use this georeferencing toolbar to tie the image to real-world coordinates. And if you don't have the georeferencing just in a blank spot, you can right-click and then come down to georeferencing and check mark that, and that will show up in your list up here. And also, it will have the name of the images that you have loaded in your table of contents. I only have one right now. Okay, so let's get to work. So I need my known points for these 6 locations on my state boundary. And what I've done is I have gone and found the coordinates of those 6 points. I have northeast. Okay, you can read, but here's how I labeled my corners. And for the northeast is, I'm calling the northeast this one, and I'm calling the inner northeast this one, and I'm calling the upper northeast this one, just so you know. All right. And I have written the coordinates that these points are into my Excel spreadsheet. And I'm going to look at these when I start entering in the coordinates that I'm going to transpose this image to. All right, now I'm going to move this out of the way, but when you start seeing me type in numbers, this is the list that I'm going off of. All right, so I'm going to move this out of the way, and we're going to start geocoding. Now, this video is probably going to be a little long. I'm sorry. I like to do my tutorials and things real time, so you can bounce around and fast forward and all that kind of stuff through all of my yakking and get to the points that you really want me to make. All right, so stay with me, and here we go. All right, so I have my first image loaded in, and I've set the layer properties to match what I think this map projection probably is, in this case NAT 83. I have my georeferencing tool loaded. I have the image selected that I'm going to be working with. Now I want to use the add control points tool, and I'm going to zoom into the northwest corner, and I'm going to set my first control point. I'm going to left click my first, because that's where the image point is, and now I get this little rubber band thing here, but I don't want to click again with my left mouse button. All right, I want to right click my mouse button, and then you get this little menu, and you want to choose input DMS, which is degrees, minutes, and seconds of longitude and latitude. So click that one, and you get this fill in the form here. All right. Now my first coordinate for longitude and latitude is the northwest point. And my coordinates I have found is for longitude is 114. For degrees, 5 minutes, 20 seconds. And we are west. We are west longitude. Okay? For the latitude, we have an even 42 degrees, 0, 0, and we are north latitude. So I click OK. All right, so you see my map kind of move a little bit, but I come up here and I right click on my image and I zoom to layer so I can see the whole thing, and you see that we have our first point set. So we're going to zoom into our second point, which is the southwest, and I'm going to click my control point tool, and I'm going to best guess where that state boundary is. That's why you could be a little off if depending on how you click. So I left click my first point, and then I right click for the second point, and the second point I'm going to hard code a coordinate. The southwest corner is 114 and 5 degrees. It's the same longitude line as the first one. Okay, and that is, make sure that's west. And our latitude is 37 degrees 0, 0 north. Okay, so we want to make sure that that's north. All right, and click OK. Then our map disappears again. It didn't really, it just moved. So you want to zoom to layer. So now you see we have our second point set. All right, so I'm going to go here and zoom into the southeast corner. Do the same thing. Click our control. Try to find the best guess where that corner is. Left click for the point, right click to bring our menu up, and we go to the southeast corner, which is 109. It kind of knew right off the bat that it was pretty close to 109. I'm hitting tab to go to the next spot. That's 6 minutes, 28 seconds. We are still west. And I can tab again and come down here, and this is also going to be 370000. Make sure that's north and west. Click OK. Map moves again. Come over here to our table of contents, right click, zoom to layer. Now we're going to go to the northeast, and we're going to zoom into the northeast, hit our control point. Best guess our first click, which is a left click, and then a right click to bring our menu up. And we are doing the northeast, right? And it says 1097, and in actuality it is 1096 and 28, and it's west, and it is 41 even. It's pretty close there. Okay, a few seconds off there, so make sure that still says north and west. Click OK. Okay, and then right click, zoom to layer. Now we're doing the inner northeast and the upper northeast. So I'm going to zoom into my inner northeast, hit my control point, my control tool, best click my first point, which is the left click, and then right click to bring our menu up. And it says 111.511. In actuality, it's 111.528, so that's pretty close. So we can tab through that and just change this to the 28. Make sure it's west. And for our latitude, we are 41 even, so we can just make this 0 and make this 0. Make sure that says north. Click OK. We have that point set. Right click here, zoom to layer. We only have one more point to do, so I'm going to zoom into here and click my control tool. I am going to left click best I can, and then right click to bring our menu up. And for the last point, it says it's supposed to be 111.528. Ooh, look at that, I'm pretty darn close. So we're going to go 28. And the last latitude is 42 even, so I'm 9 seconds off of that, which was pretty good. Make sure those both say west and north, because we're in the United States in this example. Click OK. Now we're going to zoom to our layer again. So we now have those 6 points set. All right. If you want to see how close you are in your clicking, you can come up to the View Links table, click on that, and you'll get a whole bunch of transformation numbers. Okay. I'm not going to explain a lot about these. I only want you to look at one number, and that one number is the RMS error. Okay, this is the mean squared error is basically what this is. This number here, you want somewhere, you want to try to get this number 0.02 or less. So if you notice, I'm 0.005. So we did pretty good digitizing that. All right. So anyway, any RMS error less than 0.02, you're doing pretty darn good. All right. So we don't need that box anymore. The next step is to actually rectify. We're going to save this image with these coordinates all together into a brand new image. All right. So we're going to come up here to georeferencing, and we are going to rectify where it says save current warp, which that's what we're doing to this image, is warping it. Save the current warp to a new data set. and we're going to give it a name, and it's going to save my results in my GIS data reference directory. And I'm going to give it a name. We're going to call this, we'll save the Utah part. And since I know that this was my Mercator one, I'm going to call this let's say M1. Okay, for Utah Mercator 1. This is my new file that it's going to create. And I click Save. So right now it goes out and creates a new TIFF file with the coordinate data attached to that TIFF file. Okay? So we have that one done. All right? So what we're going to do is we are going to I'm going to create a new blank session. I'm not going to save the current one. I don't need to save anything because I've already saved my image to a new TIFF file. And we're going to just start from blank. We're going to start a new project. Okay, so we have our new blank project. And I'm going to add in that conic projection. We've already done the Mercator projection. We're going to bring in this, what I think is a conic projection. And we're going to add that to our session. Of course, it doesn't have any spatial reference information. We already know that. Okay, so now I have this image. And we basically repeat the same thing that we did for the other one. So I got to come over here to Layers, right-click Properties of my layer, and choose a projection that I think that this one is in. Okay. Like I said, it's a conic projection. I can be right, I can be somewhat off. But what I'm going to do is, I got two here. I got the North America equidistance and I got the equal area. I think what I'm going to do is I'm going to pick, let's go equal area for this case. I'm not sure that's going to be exactly right, but it's a conic projection nevertheless. So I'm going to pick the Alberts equal area conic, hit OK, and now the coordinate system that I think it's in is loaded into the properties. All right. Now we look at our georeferencing, and you notice that it says we're working with the Utah conic projection now, and this one's a JPEG. Okay. So we do the exact same thing we did on the last one. So here we go. So we zoom into our first corner and we click our control tools. All right, so I'm going to yammer as I'm doing this, but we're doing this exactly how we did the first one. So I'm going to click here once with left mouse, right click, bring up our little menu. Okay, and here we go, entering our data again. So 114 tab 5 tab 20, and that is west. And for latitude we're at 40, whoops, not 420, 42 0000, and this is north. All right, so we click OK and we moved it, which is what we expected to happen. So right click, zoom to layer. Now I'm going to come down to the southwest, and I'm entering those same coordinates that I did for the other one, but we're working in a different map projection. Okay, so I'm going to left click, right click, bring up our menu. Okay, these numbers are way different, but I think, well, if you look down here, it's in meters. But that's okay. Don't worry about it because ArcGIS is doing the math for us. All right. So my RMS, I can tell you right now, my RMS is going to be outrageous, but we're still working in a conic projection, and ArcGIS is doing some math for us. All right. So, all right. So I'm in the southwest, and I'm doing longitude. So I need to change this to 114. 5 and 20 west, and latitude is, we're further south, so this is 37 even, and that is also north. So I click OK. Ooh, look at this. This is a big change, and I'll tell you why. So we're going to zoom out here, and notice that it put my map at an angle because it's a conic projection, but I think the original image is more probably a state plane coordinate where they straightened it out. Whereas I'm looking at a continental based conic projection. That's why it's based off of the projection that I'm doing it to is based off the entire continental United States, whereas it's a conic projection, but the image was probably a state plane conic projection, which made it more straight up and down, okay? But it's still a conic projection. So I'm still feeling good about it, so we'll just continue. So we're going to come down here to the southeast corner now. So we'll zoom into the southeast corner, hit our control tool, find the best point, left click, right click, bring up the menu, and let's go to the southeast. I'm not worried about the numbers that are in here because we're working in meters up here, but you can still type in your latitude and longitude. So that's 109, 6, and 28 west, and we are southeast. That's 370000, but it is north, not south. Click OK, and our map moves again. So we right click, zoom to layer, and now we're going to go to the northeast corner, and we are going to hit our control, left click, right click, menu, and for the northeast we are at 109 and 6 and 28. You would think I'd have these memorized by now, but I don't. And our latitude for the northeast corner is 41 even. Make sure that's north. Click OK. Right click and zoom. Now we're doing the inner and the upper northeast. So we're going to do the inner northeast first. So I hit my control tool, find that corner as best as I can. Left click for the point, right click for our menu, and enter our coordinates for that point, which is 111,528, 111,528 west, and our latitude is 41 even, 410000. Click OK. Now one more point. So we're going to right click and zoom into our upper northeast. Click our control tool, find that point, left click, right click for the menu, and our last point is 111,528, 111,528 west, and latitude is 42 even, 42 degrees, 0 minutes, 0 seconds, north. Click OK. We got all 6 in. We're almost there. We are almost through this bad thing. So zoom to layer. Okay, so here's our conic projection, and here are our 6 points that we hard-coded in. So we are going to project this. Let's look at the RMS. Now, the RMS is going to be really freaky. Remember how I said you want it close to 0.02 or less? If you'll notice, it looks like I'm way off, but I'm not really way off. I am in terms of the continental projection, I'm way off from the state plane coordinate system. But I'm going to trust that I chose a conic projection correctly. All right. I'm more concerned with it being a conic projection than being state plane versus a continental coordinate system. Okay. So yeah, that RMS is really bad according to what I told you on the first one, but I'm trusting my instincts here, okay? And sometimes you have to do that. So we'll get rid of the link table, and we will come up to the georeferencing, and we will rectify this to a new image. And I am going to call this one, let's see, it wants to call it conic, Utah conic. And I'm going to, since I already have one like that, I'm just going to keep the C and save it to my reference directory, Utah C1 for conic, and I'm going to save. So I'm writing out a new TIFF file for the conic projection. Okay, so both of my images are now hard-coded with real world coordinates. Let's see how we did. So we are going to create a blank project like we did on the last one. We're not going to save this because we don't want to. Now what I'm going to do is I'm going to bring in both of these images to see how well they match with each other. All right. The first image that I bring in, it will automatically assign the properties of the layer to that map projection. So I'm going to add, and we're going to bring in the, I got to go to my reference directory. Whoops. Let's go up one, two, come over to our, let's come over to GIS references. They're in there. There's our Utah C1 and our Utah M1. Let's bring in our conic projection first. All right, so we'll add that. Notice that it looks just like it did before. Now what I'm going to do is add in our Mercator. Remember, this one was straight east and west, north and south, right? So I'm going to bring in the Mercator one, add, and it automatically puts it in the same map projection as the conic projection was. All right, so that tells me we did a pretty darn good job of figuring out which map projection each one of these images were. Now, they may not be perfect on top of each other, and the reason for that is my precision in clicking those corners. Okay, I may have not, see, here's the corner of that conic projection, and here's that corner of the Mercator projection. I may have not left click that control point in the exact same spot. Okay, so this is not the GIS software's problem. This is the cartographer's problem. Did I click in the exact same spot? All right, it looks like I was just a little off in my clicking, but for images off of the internet, hey, that is not too bad. Now, the cool thing is I can bring in GIS data and put those on top of each other on my GIS data. So I'm going to come in here, I'm going to add data, and I'm going to come up to a directory that I know that I have a map of the United States. I'm going to go to this geodatabase, select states, click add, and there is real vector data of the United States, part of the United States. Notice how that I was telling you about a continental conic projection. Okay, the standard parallels were probably here and down here, and then the center of the continental United States over here. It was based off of that. That's why Utah is at this angle. Whereas our original conic image, this was straight up and down, saying that it was probably oriented for the state plane system. Okay, so let's hollow this out so we can see what's behind it. Change this to red. Click OK. And here's our images based on GIS data. Let's zoom in and really see how far off I am. Okay, so I'm a little bit off on my conic projection. Okay, the state boundary, I'm a little bit off. You can adjust that and go and make that more accurate. Let's see how well we did with the Mercator's a little different. I mean, it's not wrong, it's just the precision of my clicking, really. Okay, but for two ratty images coming off the internet, we did pretty well to get this in the right location. And like I said, this was just to give you an idea on how georeferencing works. So we did pretty darn well. If you have any comments, questions, put them in the comments. If you like this video, please like it and please subscribe to the channel and hit that bell for notifications. And thank you so much for watching. Thank you for being a subscriber. And like us on Facebook at My Physical World on Facebook. And we will see you on the next video. You guys have a beautiful day. See ya.